Again, we are going to talk about the skeletal system today. We have a few objectives, so let's quickly review the objectives. First, we need to distinguish between the axial skeleton and the appendicular skeleton, then to explain the function and structure of the bones, summarize the bone's development and elongation, list the three types of joints and give an example of each. Finally, we need to describe the common disorders that may affect the skeleton. Let's see a short video about the skeletal system.
Today we are going to learn about the skeletal system. We're going to look at what it is, how many bones do we have in our body, and what are the functions of the skeletal system. Let's start off with what is the skeletal system. The skeletal system is comprised of bones and joints. The bones provide the majority of strength, support, and help in a variety of bodily functions, as you'll discover later in the video. The joints. There are around 100 joints in the human skeleton, which enable the skeleton to move through multiple ranges of movement. Just think, without these joints we would be statues, unable to move. An example of a joint is your elbow joint, which is where your humerus connects to your ulnar and radius bones in your forearm. How many bones do we have? The typical human has 206 bones in their body. However, this isn't always the case. At birth, you are born with 300 bones. I know you're probably thinking, how do we lose bones? Where are these bones going? Well, when you're born, there is many bones such as a skull that haven't fully developed yet. This delayed fusion allows your brain to grow until the bones fuse at around 2 years of age. Skeletal system functions. There are 4 main functions of the skeletal system which help the body in their own unique ways. Protection. The skeleton protects our delicate organs, preventing them from undergoing any harm. Some examples of these are the skull, which protects the brain, rib cage, which protects the heart and lungs, and finally the spinal column, which protects the spinal cord. Shape and support. The skeleton is the body's framework, holding our vital organs in place, not allowing them to move freely around our body. Without the skeleton, we would not have a posture, and therefore look like a big blob, making movement really hard. Which leads into the next function, movement. Bones are the attachment sites for muscles. Without the muscles attaching to the bones, we would be unable to move. When you look at your arm, for example, muscles such as biceps and triceps are the reason your forearm is able to flex and extend. Also, we talked about before joints, which allow the bones a wide range of movement, and without joints, the shoulder or hip wouldn't be able to move as freely as it does. Blood production. Red and white blood cells are produced in the bone marrow, in either your humerus, femur, or ribs. These blood cells have many responsibilities within the body. Red blood cells consist of hemoglobin, which carries oxygen around the body and to the muscles. White blood cells are a vital part of your immune system, detecting and dealing with infections. An overview. What is it? The skeletal system is comprised of bones, which are responsible for the strength, and joints, which help with the range of movement. How many bones do we have? You have 206 bones during adulthood and 300 bones at birth, because like we said before, your bones haven't fully fused together yet. Skeletal system functions. You have protection, protecting your vital organs. Shape and support. The skeleton is the body's framework, holding your vital organs in place. Movement. Bones are the attachment sites for muscles. Without the muscles attaching to bones, we'd be unable to move. And blood production. Red and white blood cells are produced in bone marrow.
Great. Thank you for watching. Please finalize your notes. Okay, let's proceed with our lesson. The skeleton. As we saw in the video, that the skeleton is not just for a human, it's for all animals and other organisms. Now, the skeleton for us today, which is the human skeletal system. The skeleton is the bones of a human or animal body that form the framework of the body, supports the muscles, organs, and protect the inner organs. So support and protection is the major function of the skeleton. Plus, it gives us the ability to move or move some parts of our body. The variation in size and shape among bones that make up the skeleton reflect their different roles in the body because the structure should match the function. Now this is a picture of a skeletal system. It shows some parts of that one. As I said before, you do not need to memorize all these bones, just take a look at them. Uh, don't count them. It's only 206 bones for the adults. And as we saw in the video, it's 300 for the at birth or for the child. Who can tell me why it's more before? And when you are born, it's more bone than when you are adult. Do we donate them? Funny, huh? That's right. Because during the development and the growth of the human body, after birth, there are some bones are not completely grown up or completely developed. So in a few years, it will be developed and fuses together until finally it becomes 206 bones. Fine. Fine. So the human skeleton is composed of two main parts, the axial skeleton and the appendicular skeleton. Now, the bones of the arms, legs, along with the scapula, clavicle, pelvis make up the appendicular skeleton. The bones of the skull, ribs, spine, and sternum from the axial skeleton. Now, if we take a look at this picture, we'll see this is the axial with purple, the axial skeleton, and the rest is the appendicular, correct, the appendicular skeleton. Now, let's move on. Sorry. The bone function and structure. As we know, skeletal system is made up of bones. So what's the bone? What does it do? What's made up of? Let's see. The bones that make up the skeleton function in a variety of ways, such as supporting the muscles, protecting the internal organ, helping movement, and playing vital role in important metabolic processes. Now, bones do not make up most of the body mass. Let's talk about the long bone structure. The long bone surface is covered by a tough membrane called periosteum if you like, we pronounce it periosteum. Fine. The periosteum is a wide double-layered membrane that covers the entire surface of bone except the joint surface, and it is rich with supply with nerve fiber and blood vessel. Now, I want to ask a question here. Why at the joint surface there is no periosteum? Okay, think again. Wonderful. Because at the joints there are a lot of movements. Now when the movement is frequent, this layer may be ruptured or destroyed. So this will cause losing of blood, fibers, nerve destruction. So it's more safer not to have this surface at the joints, because at the joints we have something else to protect. Let's move on. Under the periosteum, There's a hard material called compact bone, and this part of the bone gives the bone their strength and rigidity. So, in the compact bone is the place where the rigidity and strength property is given to the bone. This compact bone is composed of cylinders made up of mineral crystals and protein fibers called lamella. Each one of these lamella is made up of the narrow channel called Haversian Haversian canal, which contains the blood vessels in compact bone. We still at the compact bone. Surrounding each Haversian canal, there are protein fibers and osteocytes. Osteocytes, this is an important word. These osteocytes are specific type of bone cell. Beneath some compact bone, there is a network of connective tissue called spongy bone, not SpongeBob, spongy bone. The spongy bone is less dense bone tissue that has many open spaces. Take a look at this picture. We have here the spongy bone beneath the compact bone. Inside, we have the marrow. We have either yellow bone marrow or red bone marrow. Now, if you notice here, we have blood vessels. These blood vessels supply the bone with blood. Actually, since the bone cells are alive, they need to be supplied with blood because they need oxygen, they need to remove wastes. In addition, that the bone marrow produces some types of white blood cells which need to be discharged into the bloodstream. So this is one important part of blood vessels which are in the bone. Let's move to the bone marrow now. The bone marrow is a soft tissue inside some bones that can be either red or yellow. The type of the bone marrow present determines both its composition and function. Great. Now, bones' function and structure. We need to describe some injury and repairs to the bones. Despite their strength, bones will crack or even break even if they subjected to certain situation or are overused. Like if you punch some solid or if you fall onto your bone, whatever your hand or your leg, this is called like a certain situation or say serious situation, and you may work out more than what you can stand for, so it's called overused. Anyway, a crack or a break is referred to as a fracture. The fracture is an injury in which the tissue of a bone is broken. During fetal development, some bones that were originally cartilage, which is soft bone, will slowly be replaced by actual bone. This process is called ossification. Ossification. Talk about the bone elongation. In bone elongation, bones continue to grow after the person birth. Of course, elongation that means increase in vertical and horizontal elongation growth. So this take near at the end of near to the end of the long bones at the area known as the epiphyseal or epiphyseal plate. The epiphyseal plate is found at the joint ends of long bones and it's composed of cartilage. This area of bone will eventually become mature bone when the elongation is finished. So, we'll talk about joints, please. Let's see this short video that summarizes the movable joints, then we will proceed to our lesson. Enjoy.
The joints of the skeleton define the motion of the body and its limitations. Hey, welcome to another episode of Proco. This lesson is about the types of joints in the human body. As artists, we really only need to learn the synovial joints, like the shoulder and the knee, because they move. Joints that are fibrous and cartilaginous hardly move, and some, like the connection of the two pubic bones, don't move at all. When you're learning how to draw, pay attention to synovial joints, and keep your thoughts away from pubic bones. If you know where the joint is on this foot, you know that it won't do this, or this, when you stand on your toes. It will do this. We need to know the position of the joint to make squash and stretch look like the real thing. Synovial joints. There are 6 types of synovial joints. They have varying shapes, but the important thing about them is the movement they allow. Joints determine what position our bodies can take. We learn them to invent poses, and we learn the limits to stretch the limits. The 6 types of synovial joints are hinge, pivot, ball and socket, ellipsoid, saddle, and plane. Let's go through them one by one. The hinge joint. The hinge is a very simple joint. It allows movement only on one axis. Its structure prevents rotation this way or this way. The head of the bone wraps around the cylindrical head of the other, allowing a very stable rotation this way. Going back to the terminology from last week, the hinge joint allows flexion and extension. That's it. That's all it does, but it does it well. Like the hinges on a door, allow it only to open or close. The best example of it is the elbow. Here's the rotation on a simplified skeleton: flexion and extension. So, if the elbow only allows flexion and extension, how is it that we're able to twist the forearm? Well, let's take a look at the next joint, the pivot joint. The pivot joint also allows rotation at only one axis. However, it rotates along the long axis. A cylindrical bone fits into a ring of bone and ligament, like the radial ulnar joint just below the elbow. The cap on the radius bone fits nicely into this notch on the ulna bone. Ligaments complete the ring, holding the bone in place and allow the radius only to rotate inside of it. The result on the forearm is what we call pronation and supination. During pronation, the base of the radius rotates over and around the head of the ulna. The ulna stays relatively still. Remember, the hinge joint at the elbow prevents the ulna from twisting, so all of that twisting happens at the radius. And by the way, the distal joint of the ulna and radius is also a pivot joint. The combination of the pivot at the top and at the bottom creates that twisting motion for pronation and supination. The ball and socket joint. The ball and socket is the champion of all joints. Hooray for the ball and socket! Its structure is just like how it sounds, a ball inside of a socket. This simple and effective structure allows it to move in all axes: flexion, extension, abduction, adduction, rotation, and circumduction. The 2 ball and socket joints of the body are at the hip and the shoulder. The hip has a deep socket, which gives it stability but limits some range of motion. The shoulder joint has a shallower socket, which gives it greater range of motion but takes away some stability. Maybe that's why a dislocated shoulder is so common. Ouch. The ellipsoid joint. The ellipsoid joint is very similar to a ball and socket. However, the ligaments and its oval shape prevent rotation. but it still has the ability to rotate on two axes, which allows flexion, extension, abduction, adduction, and circumduction. Circumduction is just a combination of all the others in a circular motion. The ball, or oval head, also slides inside the socket. When it rotates along the wider plane, you can see how it pops out too much from the socket, so it slides back into center. A great example of an ellipsoid joint is the wrist, also known as the radial carpal joint. The group of carpal bones rotate inside the socket of the radius. The saddle joint. The saddle joint is similar to the ellipsoid, but the rotation is limited mostly because of the bone structure. The structure of the saddle is very interesting. Both bones have a concave and convex surface. Convex means the surface sticks out like a hill. Concave means the surface curves in like a hole or a cave. The concave plane of one fits on the convex plane of the other. It's like a 3D yin-yang, or a cowboy on a horse. The saddle makes the bottom piece, and the cowboy's legs make the top piece. The legs of the top piece, which wrap around the body of the bottom piece, allow a rotation this way. The body of the top piece can glide inside the legs of the bottom piece. So this unique structure allows the joint to flex, extend, abduct, adduct, circumduct, and very slightly rotate. An example of the saddle joint on the body is the carpometacarpal joint of the thumb. Let's see that baby in action. Finally, the plane joint. Not really as interesting as the others, but deserves our love anyway. It's basically two flat-ish surfaces, one on top of the other. These surfaces can glide or rotate. They usually come in groups, like the carpals of the hand and the tarsals of the foot. Ligaments hold these bones together, but might allow some rotation and gliding. Another plane joint is the acromioclavicular joint. That's the one between the clavicle and acromion process of the scapula. When we elevate the shoulder, the angle in here will adjust to keep the scapula vertical.
Fine. The joints, it's the place where two bones meet, as we saw in this video. Let's see what are some important points about the joints. Actually, we can categorize the joint types in the human body into three categories: the fixed joints, the semi-movable, and the movable. When we are talking about fixed joints, that means these joints does not allow any kind of movement, like your skull. But when we talk about the semi-movable, that means it has a limited movement, which need to be aided by cartilages, like your spinal cord. When we move to the movable joints part, this kind of joints has many types. Now the movable joints actually they give a wide range of motion. So there are different types like we saw in the video, like hinge, ball socket, pivot, saddle, and gliding, and other more. And as we learned in the video that we have about 300 joints in our body. So let's start with the first one, the hinge joints. This type of joints allow limited movement in only one plane, like your elbow. The ball and socket joins another type of movement joints that allow 360 degrees movement in two planes, like your shoulder. The pivot joints allow 180 degrees movement. The saddle joint have 360 degrees movement. The gliding joint allow bones to slide over each other. So joints are very important in our body and they are very, let's say, helpful in our movement. Let's see the structure of these joints. The structure of the joints actually help to deal with pressure and stress. Of course, for everyday life, it's very full with movement. I'm not talking about the lazy boys or the lazy girls. I'm talking about the normal human. Whether you are sleeping, awake, whatever. It's not about being active or lazy. It's just normal human. So these joints are covered with cartilage and secretes synovial fluid, which reduces the friction. Also, these joints are connected with ligaments to aid in joining or joint movement. So we have two parts of the joint, which is the synovial fluid and the ligament. Even though with all this protection, the joint still can be injured.